All right, so now we'll move on to our last and final talk. So, as a USC alumni and actually my former boss as well, Peter Kim's ambitions and focus in recent years has been shaping the future of DAOs and DeFi products on Ethereum. But taking a look back in time, when he graduated from this very institution, Peter went on to consult for Ernst & Young's strategy and innovation division for 5 years. He focused on go-to-market strategies, scaling new product launches, restructuring organizations, and capturing synergies. After meeting his co-founder on an online Discord server in 2020, Peter decided to leave the consulting world behind to improve the many inefficiencies of cross-chain messaging and transactions. Together, they founded Polymer Labs and raised a $26 million Series A led by Blockchain Capital in an effort to build Ethereum's interoperability hub. Here, he's scaling the Inter-Blockchain Communication Protocol, otherwise known as IBC, across all chains to establish standardized multi-chain message passing infrastructure. Peter's mission at Polymer is to ensure that the interoperability layer connecting all blockchains is neutral, open, modular, and permissionless across all crypto ecosystems. So ladies and gentlemen, let's give a warm welcome to Peter Kim.
Thanks so much, Gabe. One sec, I just have to plug this in. Cool. Are we good? You guys can hear me? Yeah. Great. Awesome. Yeah, thanks again, Gabe. I'm here today to present on Polymer. He already gave a great introduction. I'm going to re-give it. But yeah, Polymer, Ethereum's interoperability hub. I'll be telling the story from computers to interoperability, propelling global networking. So a quick self-introduction. I'm one of the co-founders for Polymer Labs and the business lead. Previously, I was a governance leader in the Ethereum DeFi ecosystem. I helped structure DAOs, structure governance, helped build a few communities. As Gabe mentioned, I met my co-founder during that time. Prior to that, I was at EY Strategy and Innovation Consulting Practice in New York, and I'm also a proud alum of the Marshall School of Business here at USC. I'm especially excited to be here and see so many excited students, so many people that are interested in the blockchain space, and it's especially exciting because when I was at USC, there was no blockchain club. So to see not only a club, but also an annual conference come together with such great speakers and agenda, it's great work to the blockchain club at USC. So if you had told me 15 years ago that I'd be presenting on interoperability, I would have looked at you very confused. I would have looked at you as confused as people look at me today when I say the word interoperability. And part of that is because 15 years ago is around the time that the Bitcoin Genesis block was mined. Soon after that, Vitalik launched Ethereum. And I go into this history a little bit because to tell the story effectively of interoperability, it's helpful to look at how computers have advanced over time as well. So as these layer 1 and layer 2 chains launched over the past several years, most of them focused on computation, throughput, transactions per second, basically trying to make sure they get the blockchain right. But that meant these blockchains didn't connect. They didn't know how to speak together. They weren't speaking the same language. And that's where interoperability comes in. If any of you have transacted on chain, you already know how painful that is. If you've transacted trying to use multiple chains, it's even more painful. There's like at least 4 transactions you have to make before you actually see your assets on another chain. And sometimes you don't even know if it's going to make it across. And other times you don't know when it's going to make it across. So interoperability is actually what we believe one of the most crucial problems to tackle in the blockchain industry. It unlocks unified liquidity. It means users can use multiple chains much more easily, better user experience. It also means applications will be able to speak better with each other across different chains. So going back a little bit on the history, does this sound like the pain points sound familiar to anyone here? That's good. I'm glad to hear that. Also, yes, cool. He's raising his hand because yes. The pain points that we see here are similar to the pain points that were seen previously, because late 1800s, early 1900s, engineers were building out and innovating on the mechanical computer. And in the 1940s, the first digital computer was invented. For the next few decades, they were trying to make sure they got the computer right. Just like blockchain engineers are trying to make sure they get the blockchain right, they weren't really concerned about networking or interoperability. So fast forward to the 1970s, there were multiple standards that came out. TCP/IP, X25, AppleTalk, dozens of other solutions that most of us haven't heard about. Honestly, I didn't even know about AppleTalk until I looked into this history. This triggered what historians refer to as the protocol wars. And interestingly enough, since 2020, we're seeing the same thing happen in the blockchain industry. There are dozens of blockchain solutions tackling this interoperability solution. I won't act like we're the only ones. But the big question is, what will win the interoperability wars? So, for us, we believe that the ideal interoperability solution will mirror that of TCP/IP. The best attributes that came with TCP/IP and the elegance and design of TCP/IP. I've listed a few here. I'll go over a few. For example, credible neutrality. That means not just one organization builds it, not just one organization maintains it or owns it. No vendor lock-in. That means if you use it, you're not stuck using it. Many solutions in the space right now for interoperability, once you sign up, they have like non-competes or exclusivity agreements, and that makes no sense for like following the core ethos of like blockchain and technical innovation. And then no rent extraction. So think of it this way: when you send an email, you're not paying per email that you send. That's kind of what we're seeing with some of the other players in this space. Other key basic features or key basic attributes: robust features, fast and efficient, and secure. Now, during the protocol wars, as I mentioned, proprietary solutions proliferated. Apple, Xerox, IBM, many other companies built out these solutions for their own network of computers and tried to make it compatible with other networks as well. But many lacked the best attributes, namely open, neutral, and efficient. And if any of you guys have clicked into like the settings when you connect your phone or your laptop to Wi-Fi, you might already be able to guess that TCP/IP won during the protocol wars and is used universally today. Now, I want to introduce to everyone what we believe is this next generation of the internet, and it's called IBC. So IBC stands for Inter-Blockchain Communication Protocol. This is a technology that was born out of the Cosmos ecosystem. Big shout out to Jay Kwan and Ethan Buckman, who had the foresight to think of building interoperability and networking as they were building out also the Cosmos blockchain. Now, there's a common misconception that IBC can only work in Cosmos, and that's actually not the case. It's just a specification. It's just like basically the rules of a language, and it can be applied to other blockchains. So, why do we love IBC? Now, IBC addresses every layer of the interoperability problem. An easy way to describe this, and I don't want to get too technical and lose people, the easiest way to describe this is that you can compare it to the OSI model, which is the Open Systems Interconnection model. That describes how computers communicate over a network. And the two key takeaways on this slide is that, one, each of the layers here are separated. There's the app layer, the transport layer, and the network layer. A lot of solutions in what we call Interop 1.0, back in like 2020, 2021, organizations like Ren, they built, and like multichain.xyz, they built token bridges, which basically conflated the application layer and the transport layer, and that led to a solution that couldn't scale across chains and across multiple different platforms. The second key point from this slide is that on the bottom right here, we have the network layer on the blockchain side, otherwise known as the state layer. What I want to call out here is light clients. So this section, the state layer, the network layer, is what provides the most secure solution or open solution for security for interoperability. So to expand on light clients, basically they sit on different chains and they're lightweight nodes, as in they read the header of a blockchain and send a proof to another blockchain, and that blockchain verifies the state of another chain. In other words, these are establishing the connections between chain by verifying. This means they're trusting code, not trusting humans. And this is an important part that I'll dive a little bit deeper into. But the key here is that with IBC, you're not adopting new trust assumptions. You're inheriting the same level of trust assumptions as the blockchains you're connecting. So on this scale of like trust humans and trust code, this is a common theme across every category in the blockchain space, is this like whole decentralized versus centralized argument. We personally, like at Polymer, we are very big subscribers of the original ethos of blockchain technology. So we've been building our solution very much in like the trust code decentralized path. That means it frankly takes longer, which is why we haven't launched yet versus a few of our competitors. I'll get into that later. We're live on testnet. But all of these solutions that went live earlier, they tried to, they basically took shortcuts, had a centralized solution, and launched earlier. Many of them got hacked. So in the past 4 or 5 years, there's been over $2 billion lost to hacks of bridges. And they all sit on this spectrum of trust humans, trust code, centralized to decentralized. Like some big names that people might have heard of, we have listed here, like Ronin, $650 million lost, Poly Network, $600 million, Wormhole, 326, should be a million there, not $326. And Nomad, $190 million, and so on. So recalling what I was mentioning earlier in terms of the best attributes of TCP/IP, we found after doing, I guess a little bit of background. My co-founder and I were building in the ETH DeFi space. We started building out cross-chain products because we saw Solana launched, BSC launched, Polygon launched, and everyone was like wanting to move money around. So building vaults for yield, building lending protocols between chains, this was all like really hot back in DeFi summer 2020. Basically, we had firsthand experience of like how painful building multi-chain was. So we took a pause. We went through and read all of the different interop solutions that were out there and landed on IBC. And I'll share a little bit about why that is. So with its elegant design, its open and neutral design, there is no single development organization. So this is checking all the boxes of the previous slide of the attributes. There's no vendor lock-in, no in-protocol fees, robust developer features. So when you use IBC, you can also use all the open source tools that come out of the Cosmos ecosystem, and they're continuously adding more. It's fast and efficient, and there's no additional trust assumptions, as I mentioned earlier. Other than this, it's also the most battle-tested interop solution out there. So it has expanding adoption, over $30 billion in transactions annually. I believe that's in the past year. Over 110 connected blockchains. And most importantly, there's been 0 hacks. That's key. So this begs the question, why don't all blockchains just use IBC? I wish it was an easy answer, but it's not. Basically, because there's a set list of rules, specification, requirements for IBC to be natively integrated into a chain, it's actually quite difficult to integrate. It requires changes at the core blockchain level, like the logic of the blockchain itself. And there's a lot of time and resources that need to go into building these light clients. But once you build the light clients, you have that secure connection. And this is also where Polymer comes in. So with Polymer, we're launching a layer 2 blockchain that will establish IBC as the standard for interoperability. Basically, our layer 2 blockchain will have IBC built into it, and it's connected to all the different Ethereum L2s and Ethereum. So we're enabling a technology that was only in Cosmos and bringing it to Ethereum through an L2. I think I've already gone through the benefits several times, but abstracting away chains, native cross-chain dApps, more fluid user experience for token transfers and wallet usage. And on the right here, we have a graph from, or a diagram graphic from Delphi Digital as well from their annual report of last year. Trying to, I guess, paint the map of how information will flow between blockchains. So, as networking standards proliferated during the protocol wars, so too have interop solutions. Here's a quick list of a few different solutions that are tackling the same problem statement. However, these solutions were not designed with the same principles and technical values as TCP/IP. And as we mentioned earlier, TCP/IP won the protocol wars, and so too we believe Polymer and IBC will win this war. Great. So thank you so much for indulging me in this short history lesson. Hopefully it was interesting. Thank you. If you're a developer, please feel free to scan the code on the left to join our incentivized testnet. And if you're looking to join the space, we're actively hiring on the right side. It sounds cliche, but join us in building out the next generation of the internet.
So one of the challenge, now I can actually ask in a different capacity, right? So one of the challenge that we run into with interoperability solutions is sometimes there are more interoperable solutions than the actual protocols itself. Almost every few weeks, I hear about a new interop solution. How do we keep up with these solutions? And every solution that I have actually evaluated is we are going more and more, less and less trust minimalized, or whichever the right construct is. And that's one of the challenges I personally run into is how do I select interop solution based on this? We'd love to hear your thoughts.
Yeah, so I guess to summarize the question, it's how do you keep up with all the different interop solutions? Is that?
Well, that's one.
Yeah.
And then how do you know which is the most efficient?
Yeah, so I agree, it's tough. And seeing a new competitor pop up every other week is both inspiring, but also it's a tough space to compete in. I'd say the easiest way to stay up to date is there's a few researchers, probably 5 in the world, that constantly evaluate all the different solutions. We've chatted with some of them. Some of them are actually our investors. So they help keep a pulse on what's coming up. And the second question was?
The second question was more which is really the true interop solution? Because every single solution that I've looked at claims to say this is
the most efficient, the most decentralized.
Most decentralized and least trust, trust assumptions, right? And how do you measure the trust assumptions based on the number of solutions which one to select? I think that's where.
Yeah, I mean, honestly, I think that's just part of every developer's and user's job at this point to do due diligence. We actually have a report coming out in the next couple weeks of our perspective on the whole competitive landscape. We've, for the most part, been trying to build and be friendly with everybody. Given that we're getting closer to launch, we'll share a bit more about our nuanced perspective on all the different solutions. But it's a very small space, so to bag on anyone in public is not always the best path. Does anyone else have any other questions?
I'm curious, what is your funding model? How do you propose to pay for this IBC?
Business model.
Yes, business model.
Yeah.
To stay productive.
So there's much less focus on monetizing right now. It's more so on adoption. Of course, we have the levers put in place to monetize over time. The way that I don't know how I'll try to describe it with one of the pictures. So here in this slide, basically, when you want to trigger a transaction on another chain, you have to trigger a transaction on the first chain. Right now, what that means is like approving a transaction, executing a transaction, and then executing a transaction on the other side. That process will be abstracted away by what you see here in the middle called relayers. You'll submit a transaction that will pay for the gas, pay for the light client update fee, and then also pay the relayer itself to do the transaction. Basically, you can build in any step of that, like small number of basis points that would be marginal to the transaction cost itself. So that's one way to make money.
And a follow-up question, do you foresee an airdrop happening?
I don't think I can answer that. But we have a test net up, so.
Okay, thank you, Peter.
Great.
And now I'll pass the stage on to Gabe, who will do the closing address, so please stay for that.
All right, so this officially marks the end of the 2024 VanEck Southern California Blockchain Conference. I think it went pretty well, you know, nothing blew up. Celebrate that, I guess. But in all seriousness, I want to give a warm thank you to each and every one of you who took the time to listen to our great speakers in the last 2 days. We did this for the community, so we can only hope that we were able to provide value for everyone sitting before us today. Thank you to our wonderful speakers who kept the audience engaged up until the end, and thank you to our sponsors, VanEck, EduDAO, Ava Labs, Gauntlet, and Pluto, for supporting us throughout each step of our vision this year. And last but not least, I want to thank each and every member of Blockchain SC that skipped class, stayed up late nights, took a quick break from drinking on spring break, lost sleep, blood, sweat, and tears, all so that this year's conference could be a success for a very valuable group of people other than themselves. Gio, Emily, David, George, Luca, Elmira, Carson, Thurin, Trevor, Jonathan, Shreya, Vince, Daisy, Harneet, Uday, Richard, Sean, and our VanEck man, Eric Chung. You guys are the real MVPs. With that, let's bring the 2024 VanEck Southern California Blockchain Conference to a close and enjoy our weekends. Go relax, go have a drink. Thank you to everyone for coming today. We hope to see you next year.